With what you've learned so far, feel free to pause the video and try out question 3. A is directly related to what we're from calculating previously. So calculate the percentage ionization of this solution. How do we go about it? We are given the initial concentration of formic acid, and then we are told it has got a pH of that. So we know that the pH, or we can even write the equation for the sake of understanding. So we have formic acid. So you know that when it's dissolved in water, it's going to lose a proton. So it will be HCOOH. It becomes negative plus a proton. So the initial concentration was 0.025, and then HCOOH, we didn't have anything at start. The change, of course, is minus x plus x plus x. So we understand that in this case, x itself is going to represent the concentration of what? The proton, right? So the pH is dependent on the negative log of the x, which is or the hydrogen concentration in other terms. So pH has been given to be 2.75, and then we have the negative log of the hydrogen ion concentration. So some of us who've done logs know what to do here. Divide both sides by a negative. The negative goes on the other side. You know this has got a base of 10. This 10 can go the other side, so it becomes 10 to the power negative 2.75, and then it will disappear on the other side. So 10 to the power negative 2.75. What value am I getting? 1.778 times 10 to the power negative 3. That's the concentration of the hydronium ion, or the value of x in other terms in this case. So first, to find the percentage of ionization, it's this x divided by the initial. So the 1.778 times 10 to the power negative 3 divided by the initial 0.025 times 100. So the value that I'm getting is 7. In fact, we have to multiply by 100 here, 7.11%. That's a percentage of ionization. Is it appropriate to assume the degree of ionization is insignificant in the ice table for calculating the change in this ionization of formic acid? No, not necessarily. It's not. It is not insignificant. Yeah. So it is not appropriate, actually. And then B says calculate the Ka for the formic acid. How do you calculate the Ka? Don't forget we've already found the value of x. So we can just extend our table again. So we know here it was 0.025 minus x. So was it the other end plus x plus x. So first, to find the Ka, it's going to be dependent on these values. So we've already found the value of x. We can just go on and even substitute, right? So where is x? We have 1.778 times 10 to the power negative 3. 1.778 times 10 to the power negative 3. 1.778 times 10 to the power negative 3. So our Ka expression is going to be the products, which will be 1.778 times 10 to the power negative 3 coming twice, to be squared over our reactant 0.025 minus 7.78 times 10 to the power negative 3. This is what we are trying to divide to find the value of Ka. So 1.778, what have I done here? 1.778 times 10 to the power negative 3. So it squared divided by 0.025 minus of it divide. So the value of k that I'm getting on my calculator is 1.36 times 10 to the power negative 4. That's a constant I'm getting on my calculator. So if we go by the number of significant figures, we have here 3 significant figures. The least we have is actually 2. So we may end up writing it as 1.4 times 10 to the power negative 4. Okay, so this is where we end for this question.